Write the equation of the conic in vertex form and give its vertex, focus, and directrix. Then graph it. If we want this conic in vertex form, and we can see that these equations are actually parabolas, we know this because parabolas only have one of the variables being squared. If the other variable is not squared, then you have something in the form of y squared equals x, or x squared equals y. That's showing us that we have parabolas. Since we know it's a parabola, we want it in vertex form. We know that vertex form is in the form of a times x minus h, quantity squared, plus k, where h and k is our vertex. Okay, so if that's the case, we know that we need to complete the square to get this perfect square trinomial to turn into a binomial squared. So to do that, we take a look at the terms. We know that the x is not something we want to complete the square with, so we're going to actually move the x over. And at the same time, since we're completing the square, why don't we actually move the 49 as well? We don't need the 49. So what we end up with now is negative 2y squared minus 20y, and then equals negative x plus 49. From here, we know that to complete the square, we need a coefficient of 1, and so that negative 2 is kind of in the way. So what we can do is factor out the negative 2. We'll be left with y squared plus 10y, and then we'll leave a blank. We're going to complete the square here, and then equals negative x plus 49. So to complete the square, remember what we do is we take the 10, the b value, divide it by 2, and square it. Keep in mind that on the other side, you must add the same thing, 10 over 2 quantity squared. But that's not all. Notice that the 10 over 2 quantity squared, it technically has a multiplication factor of negative 2. So not only should we be adding 10 over 2 squared on the right side, we should be multiplying that by a negative 2. All right, so when all is said and done, now we know that we have a perfect square trinomial. So now we have negative 2, and our perfect square trinomial turns into y plus 5 quantity squared equals negative x plus 49, and then 10 over 2 gives us 5 squared is equal to 25, and 25 times 2 is 50. Don't forget it's a minus 50. Okay, so now when simplifying this now, 49 minus 50, why don't we just rewrite this? That'll become negative 1. Okay, and then from there, we want to solve for our y squared. So we're going to move that negative 2 over to both sides, or to the other side. So we'll now get y plus 5 quantity squared equals, and then if we just kind of see that they're all negatives, we can actually factor out that negative. That'll become a 1/2 times x plus 1, basically. Okay, so now what we see is we have the parts that we need. We have our y being squared. We have our x contained within parentheses. That'll help us to determine our vertex. So our vertex, remember that if you ever have values contained within parentheses, you're kind of thinking of its opposite value. So our vertex is going to be, if this is x plus 1, it's going to shift left 1. And so that vertex is actually going to be at negative 1. And then if that y value has a plus 5 attached to it, then that means that we're going to shift it down by 5. So we're going to have negative 1, negative 5. And then lastly, recall how that 1/2, it acts very similarly. It is in the same place as the, over here, it's in the same place as the 1 over 4p. So now we actually need to figure out what that 1 over 4p is. Okay, so if 1/2 is the same as, let me rephrase that actually. Notice how we have that y squared. We have the y squared isolated. What it's equal to is actually equal to 4p. Okay, so because you have the y squared isolated, you notice that it's going to be equal to 4px. So going back here, if this is a y squared equals 1/2 is the same, is the equivalent value of 4p. So when solving for p, we just divide both sides by 4, and so we see that p is a value of 1/8. Okay, so that's going to be important in finding our focus and directrix. Let's go ahead and plot our values now. we see that our vertex is at -1, -5. Here's my origin, 0, 0. And so I want to go -1, down 5. 1, 2, 3, 4, 5. -1, -5. I actually should label these. 5. Here's -5. Here's -5. 2, 3, 4, 5. Here's 5. 1, 2, 3, 4, 5. Here's 5. Okay. So from there, we have our vertex. And remember, because the equation, this equation right here, is technically in the form of like a y squared equals 4px, we know that this particular parabola would be facing to the right, not to the left, because if it were to the left, you'd see a negative sign there. We don't have that. So therefore, it's going to face to the right. And then also remember that your p-value is a length of 1/8. So from the vertex that we have there, we're just going to go to the right by 1/8, and that is really, really small. So you're going to hardly see it. Here's our focus. Okay, so our focus, if we know that we're actually moving to the right by 1/8, think about what that coordinate pair is going to be. Keep in mind that our vertex is at -1, -5. So if you move to the right by 1/8 from -1, that would place the vertex at -7/8, comma, -5. Okay, so that's going to be our point for the focus. It's going to be at -7/8, -5. Lastly, we're going to want to find that directrix. Keep in mind that whatever you do to one direction, you also go in the other direction. So in terms of going in the other direction, if your vertex is at -1, -5, then you want to go to the left by 1/8, and so that'll place us at -1 and 1/8. So x is equal to -1 and 1/8. Pretty close to that vertex. So I'm just going to draw a dotted line right here. I know it's not going to be exactly where I want it, but this just gives you a rough idea of what it should look like. Okay. And then we can also have our parabola wrap around. Now, you could test some points if you want. If you want to figure out that if x equals 0, where's my y going to be? Right, you could do that. So if you plug in, let's say x equals 0 in here, you'll get 0 plus 1. That'll give us 1/2. What's the y value? Oh, well, we're going to have to square root that, right? The square root of 1/2, that'll give us root 2 over 2, plus and minus, and then we also have to subtract 5. So our y value will be -5 plus or minus root 2 over 2. That might not be the easiest thing to graph. Let's go ahead and figure that out on the calculator. So let's go to our scientific calculator. And we said we needed the value of -5 plus square root of 2 divided by 2. And that's going to be a value of -4.29. Okay, so here we are at -0. We'll be at -4.29, roughly around there. Oops, let me change colors. Right there. And then remember, because of symmetry, you'll have it on this side as well. So your parabola is going to wrap around like this. Try to make it as curvy as you can. Do your best. Okay? I know that this was a particularly hard parabola to draw just because it was such small numbers. One thing you'll notice is our parabola is a fairly slender parabola, and one reason for that is because the closer the focus is to the vertex, the more slender the parabola will be. As that focus comes outwards, it's kind of relaxing that parabola, and so the further the focus is from the vertex, the wider your parabola will become. So just an interesting fact there, just something to be aware of, that the closer your focus is to the vertex, the more slender your parabola will be. The further your focus is from the vertex, the more wide your parabola will be. Okay? All right, that'll be it for today.